Hey guys, welcome to CPM 3. This is Module 2, Lesson 2. Let's jump right on in here. So, we're going over functions today. So, Objective 1, we need to identify relations, domain, and ranges. So, a set of all ordered pairs is called a relation. The set of all x coordinates is called the domain. The set of all, this should be y coordinates. The set of all y coordinates is called the range. So if you can just remember x and y, domain and range. So the first one says find the domain and range of each relation. So when you have a list of ordered pairs and you're listing the domain, you need these like same little squiggly brackets. I'm really bad at these squiggly brackets. Mine looks something like this. If you want to just do like some squiggly lines, I don't care, but they're not parentheses, okay? So my domain here, ooh, that's bad. Okay, whatever. My domain is all of these x coordinates here. Now, typically we like to list them from least to greatest, but if you just list them, it doesn't matter. My math lab will take it in any order. I will take it in any order, but I'm going to do this from least to greatest. So I'm going to go -5, -1, 0, and 3. Ooh, that's actually a decent one right there. And then my range then is all of, do this in a different color, is all of my y coordinates. So again, I'm going to list this in from least to greatest. And notice that you've got 2 -2s. You don't need to list them twice. Now again, if you list it twice, that's fine. You're not going to get that counted wrong, but you don't need to. So, least to greatest, we have got -2, 0, and then 3. B, do the same thing, domain and range. So domain means all of your x, and that's a good squiggly bracket. So your x, we've got 7, 7, -3, and 0. Again, you don't need to list this -7 twice or this 7 twice. Okay, you just need to list it once. So I'm going to go least to greatest, so -3, 0, 7. And then your range, God, I'm getting good. That's a good bracket. Is your y, -4, 8, 0, and 6. So least to greatest, we got -4, 0, 6, and 8. So then we need to identify functions. Now, it says here some relations are also functions. This is your definition of a function. Your definition of a function is given from your book. Any book ever gives you this exact same definition, and it's the world's worst definition I've ever read in my life. It says a function is a set of ordered pairs that it assigns each x value exactly one y value. What in the world does that mean, right? What this means is that your x coordinate cannot repeat. Taught with another teacher, and she said x can't cheat. Okay, so you only need one x in all of these. So when you're wanting to determine whether it is a relation, you don't even need to look at y. Y means nothing in this case. You're just looking at x. So these are the same as what we just did up here, exact same problem. So let's determine whether these were functions. So look at just your x. You've got a 0, a 3, a -1, and a -5. Does x ever repeat itself? No, it doesn't. So that means yes, it's a function. Okay, so if you notice on this one, my y repeated. We had -2 twice, but that doesn't matter because we're not looking at it. B, do the same thing. Look at only your x's. We've got 7, 7. Well, I don't even need to keep going. X is already repeated. So this one is no, not a function. Okay, to continue with that, when it is on a graph, it's actually even easier. You have this thing right here called your vertical line test. And it says if a vertical line can be drawn so that it intersects the graph more than once, the graph is not a function. So like right here, you have a sideways parabola. When they put this horizontal line through here, it intersects right here and twice, so that makes it not a function. Notice that they can put a line here and it only touches it once right here. But if I can put it anywhere where it touches twice. So in example 3, these dots came out pretty, not very bold. You got a dot here, a dot here, a dot here, and a dot here. And this one, is there anywhere where I can put a line through? Well, no, I can put a vertical line here, 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 here. It never intersects 2 points. So this one is a function. Okay, now on this one, I'm going to make these dots a little bit bolder again. We've got 4 more dots on this one. Is there anywhere I can go where I can put a vertical line through here and hit 2 of these dots twice? Well, I can put one through here and it only touches it once, right? But because I can put it here and this vertical line touches it here and here, this means your x is repeating right here. So this is not a function. Okay, on this one, is there a place you can put that vertical line in where it touches this line twice? Nope. So that makes it a function. Okay, what about this? We have a horizontal line. Is there anywhere I can put a line through here and touch that twice? Nope. So a function. Okay, this is a parabola. We're going to end up graphing these in the next module. Anywhere I can put a vertical line and touch this thing twice? Nope. So again, a function. Okay, what about this one here? Well, a vertical line definitely does not pass this. And so that's what this right here is saying. This vertical line test works on all graphs on a, oh, no, that's not what that says. Just kidding. Because it's a vertical line, you're hitting this thing, sorry. You are hitting this and like everywhere more than once. So this is not a function. And then this one here, so, you know, again, kind of be careful here. You can put a line here and only touch it once, but because I'm putting it anywhere else and it touches it multiple times, here and here, that makes it not a function. All right, so now it says to recall that the graph of a linear equation of a line, okay, sorry, let me reread that. Right here, recall that the graph of a linear equation is a line, and a line that is not vertical will pass the vertical line test. Thus, this is what I thought was the other part. Thus, all linear equations are functions except for the form of x equals c, which is a vertical line. Okay, so basically what it's showing is what we have already done on this page here. We have a diagonal line here, and I had a horizontal line here. These were both a function. The only line that was not a function was a vertical line test, because a vertical line test cannot pass the vertical line test. So unless I see this right here, the answer is yes. So y equals 2x plus 1. That's a diagonal line with a positive slope going up. So this is a function. This right here, okay, so it's not in slope-intercept form, but I know it's either going a positive slope or a negative slope. So this is a function. Okay, on C, this is sort of a typo here. This is this one here we're going to skip because this is not a line. Okay, my bad there. Here you got y equals x. X means that slope is positive. So that is a function. Y equals 5. Y equals 5 is a horizontal line. So that is a function. So here, x equals -1. That's your vertical line. This is not a function. Okay, and so that's what this is showing right here. That's your x equals c. X equals a constant, a number. And so that's your only one that's not, is when you have x equals. So x equals a constant, like this one here, is your only line that is not a linear function. All right, so getting into the bulk of this lesson now. We went over a relation, we went over domain and range, we went over a function. Now we're using function notation. So, says here, we often use letters such as F, G, and H to name functions. For example, this symbol here means function of x and is read as f of x. This notation is called function notation. We can use function notation to write the equation. Instead of having y equals -3x plus 2, they're taking this y and replacing it with f of x. So f of x equals -3 plus 2. Only difference there. So because of that, y and f of x equal the same thing. Y equals f of x. So whether it says y equals or f of x equals, it means the same thing. So when we are using function notation, the ordered pair x comma y is now in the form of x comma, instead of y, it's f of x. So, write the corresponding ordered pair solution. Instead of them writing an ordered pair as in x comma y, they're writing it in this notation here. Means the same thing though. So we have to figure out which one of these does x represent 4 or 8 and which one is y. So if you can just remember that this is usually f of x, we are replacing this x with this 4. x is 4. What f of x equals is your y. So this is your y. So my ordered pair is 4, 8. And you will have a test question like this. And this is as easy as it is. The numbers are in order. Just put them side by side with a comma and parentheses. One of the most missed questions on tests. Okay, don't overthink it. Don't make it harder than it needs to be. Whatever is in parentheses is your x. Whatever it equals is your y. So my ordered pair here is -5, 0. C, whatever's in parentheses is your x. Whatever it equals is your y. So this is 11, -13. Okay, don't make that too hard. So, given f of x equals 5 plus, or x plus 5, find the following, then write the corresponding ordered pairs generated. Okay, we've got 7 different problems with this one. Here we go. On A, we're used to this function here. And actually, you know what? I'm just going to go ahead and write this. On A, my function is f of x equals x plus 5. And I'm going to have to write this so much smaller. I'm sorry, guys. Okay. On A, they're telling me f of -2. So I'm going to replace, I'm going to keep my f, but I'm going to replace what's in parentheses with that -2. If I am replacing this x with a -2, I need to do the same thing to this x as well. When you have something in parentheses, let's do it this way. When they tell you a number in parentheses is something, this means your x. When they tell you f of x equals a number, this is your y. So because my number in parentheses is -2, I'm replacing this x with the same thing. They replace this x with -2, I'm replacing this x with -2. So now we got -2 plus 5. So we get f of -2, that's just notation, just bring it down, equals -2 plus 5 is 3. That's my answer. Write this as an ordered pair. What's in parentheses is your x. What it equals is your y. Okay, let's try again because B is the same thing. I'm going to rewrite my problem. We got f of x equals x plus 5. They're telling me f of 0. So I got f of 0 equals, if I replace this x with 0, I'm replacing this x with the same thing. So you got 0 plus 5. So f of 0 equals, it's just notation, bring it down, 0 plus 5 is 5. So this is my answer. And then my ordered pair is, what's in the parentheses is your x, what it equals is your y. C, same thing. Okay, rewrite the problem. We're doing f of 5. If I replace this x with 5, I'm replacing this x with 5 as well. So we get 5 plus 5. So we get f of 5 equals, that's just notation, bring it down. 5 plus 5 gives me 10. So what is that as an ordered pair? What's in parentheses is your x. What it equals is your y. Okay, now this one here is a silly one. When I have f of 3m, same concept as before, even though you got a variable. What I replace this x with, I am replacing this x with the same thing. So because now x is 3m, we have 3m plus 5. Simplify if you can, but on this one, can I combine a 3m and a 5? No. So this is my answer. Still put this as an ordered pair. What is in parentheses is your x. So in parentheses is 3m. What this equals is your y. This equals 3m plus 5. Okay, it's a weird problem. Doesn't do much for us, but that's what we do. Use the same process. Okay, on to E. Rewriting my problem. Now we have f of m plus 2. So if I'm replacing this x with m plus 2, I am replacing this x also with m plus 2. So we have m plus 2 for my x. Bring down your plus 5. On this one, we can combine. I can combine my 2 and my 5. So we get f of m plus 2 equals m plus 7. So my ordered pair is, what's in parentheses is my x. So m plus 2. What it equals is my y. So m plus 7. Okay, on F, I'm rewriting my problem. Now this one is now different, right? Now they're telling me f of x equals 4. Because f of x equals 4, I am oops, that's not what I wanted to do. I am replacing this whole thing here with what f of x equals. What does f of x equal? F of x equals 4. So I'm replacing this whole notation with 4. So now solve for x. So to get x by itself, we're going to subtract our 5 over. So we get -1 equals x. So what is the ordered pair that goes with that? Well, my x is -1. What we plugged in for f of x is my y. Okay, let's try another one like that. G's the same thing. So we've got f of x equals x plus 5. They're telling me here f of x equals 0. So I'm going to take this whole thing here and replace this with 0. Bring everything else down. Solve for x. So subtract your 5. We get -5 equals x. So then your ordered pair, your x is -5, And we plugged in a 0 for f of x, which is the same as y. Okay. So 7 is the exact same thing. What I suggest you guys do is pause this video and see if you can do these, how many you can do. Okay, I'm going to go through these as well. But again, I would recommend you guys pause it, see what you guys can do. I'm going to change up colors. Let's go red. Okay. A equals, or part A. Now I have, this is technically g of x. Let's just make this f of x since I made all of these f's. Okay, typo again. So we got, I'm going to scoot this over. All right, we've got f of x equals 2x minus 5. So I'm going to use this for all of these problems this time. So now we have f of negative 3. So if I replace this x with negative 3, I'm also replacing this x with negative 3. So bring down your f of negative 3. It's just notation, so just keep it and simplify. You got 2 times negative 3 is negative 6. Negative 6 plus or minus 5 gives me a negative 11. So my ordered pair is what's in parentheses is my x. What this equals is my y. B. I'm going to rewrite my problem. We've got f of 0. So I've got 2 times 0 minus 5. What do I replace this x with? I'm replacing this x with the same thing. 0 times anything is 0. So we get f of 0 equals negative 5. So your ordered pair, what's in parentheses is your x, what it equals is your y. C, we've got f of 4. What I replace this x with, I need to replace this x with the same thing. So we've got 2 times 4 minus 5. So f of 4 equals 2 times 4 is 8, minus 5 is 3. So my ordered pair, what's in parentheses is your x, what it equals is your y. Okay, on D, we now have f of 6r. So what I replace this x with, I'm replacing this x with the same thing. And you know what? I don't have enough room for this one. So I'm going to move this one up. Sorry, guys. Okay. Again, what I replace this x with, I'm replacing this x with the same thing. So we've got 6r. Bring down your minus 5. This one we can simplify. So f of 6r, that's just notation, bring it down. 2 times 6 is 12. And then bring down your minus 5. So your ordered pair here is 6r, comma, 12r minus 5. X is what's in parentheses. What it equals is your y. Okay, on E, now my f of x equals f of r minus 8. What I replace this x with, we're replacing the other x with it. So 2 times r minus 8. So distribute. We get 2 times r and 2 times a negative 8. And then combine like terms. So f of r minus 8 equals 2r. Negative 16 minus 5 gives me a negative 22. Okay, so what's my ordered pair? What's in parentheses is your x. What it equals is your y. Okay. F Okay, when I have f of x equals 5. Same thing as up at the top. I am replacing this f of x with what they tell me f of x actually equals. So this right here becomes 5. They tell me f of x equals 5, so replace that whole thing with 5. So 5 equals 2x minus 5. So solve. We're going to add our 5 over. We've got 10 equals 2x. Divide by 2. I'm going to put this answer over here so I won't have room over there. Okay. So that x equals 5. So then my ordered pair is 5 because x equals 5. And then what we replaced f of x with, which was 5. Okay. And then I'm going to try and fit g over here. I'm going to have to write small though. Okay, on g, I have f of x equals 2x minus 5. They tell me f of x equals 0. So in place of this whole thing, we are replacing this with 0. So follow your steps. Add your 5 over. We get 5 equals 2x. Divide by 2. And we get x equals 5 over 2. So then your ordered pair, x equals 5 over 2. And we replaced f of x, which is y, as 0. Okay. Lots of work on that one. In all honesty, it's not hard work, but you do have to practice enough that you get used to the notation and get comfortable in how to use it. Okay, that's what's kind of the difficult on this stuff. Okay. I wish I could say this was the hardest part of this lesson, but it is not. On example 8, we need to find the domain and the range of each function graphed. We're using interval notation. Okay. We are finding domain and range. So when I find domain has to do with all of your X values. Range has to do with all of your Y values. Okay, that was the very first page. What's kind of hard about this is you can't see my pencil, so you can't really see what I am doing, so I'm going to make little scribbles, okay? When you're finding the domain, since it has to do with all of your X values here, when you find your domain, you need to move your pencil. Let me go to another color. You need to move your pencil from left to right. So pretend like these green marks are my pencil, okay? We're starting here, and I never touch the graph. So I go to kind of the next number. -5, again, it never touches the graph. You've got -4, never touches the graph. But hey, look right here, at -3, it finally does touch the graph. It has nothing to do with the X and Y intercept, so I don't care that this crosses the X-axis at -2. You're wanting to find what values of Y do we have in this graph. This value right here for this one, it has a Y or an X value of -3. So this graph here starts at -3. Because this is a closed circle, this is going to get a bracket that has like the same thing as that is your greater than or equal to. Okay, that closed dot means bracket. So then comma, what is the largest number this is going to? So again, this is my pencil, right? It's touching a -2, -1, 0, 1, 2, 3, 4, and it stops touching right here at 5. So my largest X value is this 4 right here. So this is going to 4. Again, closed circle means a bracket. So that is my domain. Okay. So then my range. My range has to do with my Y values. So when you write this in interval notation, you need to go from the bottom to the top, bottoms up. So this is again my pencil. Okay, you're starting down here at the bottom. We have no Y values at -6, not at -5, at -4, at -3, at -2, but hey, now we have something at -1. So, closed circle means bracket, so -1, comma. Now, how high is this graph going? So you've got some graph at 0, at 1, at 2, at 3, at 4, at 5, and then nothing at 6. So my highest one is at this 5 right here. So at 5, and again, closed circle means bracket. So that's your domain and range. And so this is showing you kind of how to think of this, but this right here is what we're using the pencil for. Okay, is to think of it from left to right and then from bottom to the top. So let's try again on B. Now, unfortunately, B can get even more confusing, okay? When you look at this graph on B, I think what's so confusing about this is that when we look at this parabola, we say this parabola is going up, right? Pointing up, pointing up. But as this graph is pointing up, this graph keeps getting wider and wider and wider. Okay, so it's not just going up, it's also going out. When you move your pencil from left to right or from bottom to top, when you hit an arrow means infinity. Okay, so I don't know how to write this. We'll just put arrow equals, it could be negative infinity or infinity. Okay, it can equal either of them. So on B, when we're looking for domain, and domain has to do with your x-axis, we're going when we're looking at our domain here, domain means the x values, so we're going from left to right. So remember, these lines represent like my pencil. You're just moving your pencil horizontally through this graph. You're not touching anything at -1, or sorry, at -4, at -2, at -3, but at -1, we finally come across this arrow. So this arrow, because it's on this left side here, that means my domain is negative infinity. And remember, with these infinities, you always go parentheses, right? Soft bracket. This is negative infinity because if you notice, it's starting here at -1, right? As far as the lines go. But when this goes out a little bit further, well, now it's touching at -2. When this goes out a little bit further, it's now touching -3. When this goes out a little bit further, it's now touching -4. It's never going to stop going out and going to keep not touching all of these negative x values. So negative infinity. So arrows just mean negative infinity or positive infinity. So then how far to the right is this graph going on my x coordinates? So we're at 0, 1, 2, 3, 4, 5, 6. At 7, I encounter another arrow. So that means to infinity. And again, parentheses. You want to say, well, no, it stops at 7, but it doesn't. Here at 8, if this goes out more, it's going to touch. Here at 9, if this goes out more, this is now touching at 9. It's going to keep touching all of those positive numbers going that way. So now my range has to do with the y values, so we go from bottom to top. So -6 is not touching, at -5 it's not touching, at -4 it's not touching, at -3 it's not touching, but right here at -2 now it is. So we got -2. It's got a closed circle here. So bracket -2, and then how high is this going? So it's touching at -1, -2, 0, 1, 2, 3, 4, 5, and then we touch those arrows. It's going to keep going up forever. And so how high is this graph going? It's going to infinity. And again, this is showing you the same thing your pencil is doing. Okay? So C and D don't have any to help you think about it like this. Let's go through these a little bit quicker. Come and ask me for help if you need it. These are hard until you get the hang of it. Okay, I'm just saying. Domain. Domain is my x, left to right. So when are we first touching this graph? When does it first have an x value? Is right here at -4. Closed dot means bracket. So -4. And then what is the highest number this is touching on your x values? Okay, this way. I'm going to kind of skip some in the middle. We've got 3. And by the way, this is an x-intercept. It is not how far it is going, right? Because you still get x values here at 3, even though it's below. That does not matter. That's why the pencil is so important. So we get something at 1 right here. We get something at 2 right here. Something at 3 right here. We have 4. We have 5. We have 6. But we have no 7 here. It stops right here at 6. And again, closed means bracket. So 6. Okay, and if you notice, that's your x. That's your x. So range, y values from bottom to top. Lowest value, you have nothing at -6. We're not touching at -5, -4, -3. Here at -2 though, we're finally come across that graph. So -2, close circle, so bracket. And then how high up are we going? We got something at 0, we got something at 1. It's crossing, but it keeps going. You got something right here at 2, then at 3, that's as high as it goes, because then it's not touching that graph there at 4, right? At 4, you're just below that graph, or you're above the graph. So it goes to 3, close circle, bracket. Okay, on D. Domain. To right. So the very left of this graph, we already encounter an arrow. So we get -infinity. How far is this going this way? At the very end of the graph, we encounter another arrow. So positive infinity. Okay, and again, this one's kind of confusing like this one is here. When you look at this graph, this is your absolute value graph, we see that it is going down. But as this is going down, it's also going out. It's going to continue getting wider and wider and wider. So it's going to keep touching all of these x values infinitely in both directions. And then your range, bottom to top, right? Bottom to top. Nothing at -6, nothing at -5. At -4, we get an arrow. So -infinity. Keep going. Even though we encounter another arrow, we still have graph above, so we're not done yet. 0, 1, 2, 3. Nothing up here at 4. So 3 is the last one here, and it's a closed circle. So bracket. All right. Last page. Example 9 and 10. And these last 3 examples are all the same thing. Okay, it says use the graph of the following f of x to find each value. So they are basically giving you half of an ordered pair, you are finding the other half, right? So when f is -1, remember that's the same as saying in parentheses is your x is 1. We do not know what it equals. We do not know what our y is. So because this represents our x, go along your x-axis here to when x is 1. Go up or down to meet your graph. we don't have anything here above this, so I'm not going up. In order to meet this graph, we need to go down. So here is my point when x is 1. When x is 1, what is my y coordinate? We'll then go off to the side here, and y is -4. Okay, this is about to get really busy. I'm going to do a lot of these arrow looking things. Okay, so now when f is -3, this is your x, when x is -3. So go here to when x is -3. Now this time I'm not going down because there's no graph below. So this time we're going to go up to meet our graph. When x is -3, what is my y? So now go off to the side, and y is 4. F of 0. These 0 ones are the most confusing. When x is 0, so along my x-axis, when x is 0, what is y? You have no graph above this, so that means we are going below. When x is 0, what is your y? Your y is -2. Now these are switching gears. Now find x such that f of x equals 2. So because I'm finding x, this means I do not know my x coordinate, but my y coordinate is 2. So now go along your y-axis here. When y is 2, what is your x? Meet your graph, but now we're going left to right. So we have no graph to the right, so that means I need to go to the left. There is my point, so what is my x that goes with it? X is 2. X is -2, sorry. Okay, E is the same thing. I'm going to put a little y here. That means when y is 2. So now when y is 0, so we're going along our y-axis. When y is 0, what is my x? You have no graph to the right, so go to the left. And let me go to a different color. I don't know what other good color is going to show up. I'm sure lime green is the best next one. So when y is 0, we have no graph to the right, so we're going to the left. My point is right here, and that is -1. So my x equals -1. Okay, let's try this 2 more times. When a is f of 2, that's your x. When x is 2, which is right here, what is your y? Well, you don't have to go up or down to meet this one. It's right here. My y is 0. Okay, f of 1, again, that's 0. That's your x. When x is 1, I have no graph above, so we're going down. When x is 1, right here, what is my y? My y is -1. Now this one means when y is -3. So my y here, when y is -3, I have nothing to the right, so we're going to the left, right here. My x is -1. And my favorite, the zeros. When y is 0, okay, and let me switch colors again. I'm going to go green. When y is 0, so go along your y-axis. When y is 0, what is your x? On this one, you have two answers because it meets it going in both directions. When you go this way, your y, when your y is 0, your x is -4, as well as when you go this way, it's also 2. Okay, so it has 2 of them. We're going to find the domain and range. When we find the domain and range, let's pretend like these came with arrows. We're going to do the same thing on this one when we get to it. Okay, so my domain are my x values. And when we go our x values, you go from left to right. So start with the leftmost of the graph. When we hit that, we hit it, but we hit an arrow. An arrow means negative infinity. And then come over here, it keeps hitting all the way to here, and it hits at that arrow again, so to positive infinity. Your range is your y values. We're going from bottom to top. So we don't hit this graph at -5. We don't hit it at -4. We finally hit it at -3. And it doesn't have an open circle, so let's just go with a bracket. And then how high does this go? So it's at 0. I hit it at 1, and I do hit it at an arrow. When I hit it at an arrow, it means that this thing's going to keep going up forever. So it's infinity. What are your x-intercepts? And now I wish I didn't write on that graph so much. Your x-intercepts, remember, is where this hits your x-axis here. So it hits this graph right here. Let's see if yellow shows up better. Okay, shows up right here. Write this as an ordered pair. So because that really doesn't show up very good. Okay. Because this is at the point x equals -4, to write this as an ordered pair. This is -4, 0. It also hits here. And this is x equals 2. So 2 for x, 0 for y. Now what are your y-intercepts? Where does it cross this y-axis? Crosses right here. And this is at y equals -2. Because it's y equals -2. You got -2 for your y, 0 for your x. This video is getting very long. So what I'm going to do is I want you guys to try this problem on your own. And I'm going to just give you the answers. See if you can get the answers. And if you cannot, come and ask me. Okay? So A, this is going to equal -2. B is going to be -3. C C is going to be x equals 0. D is going to be x equals -2 and 2. Your domain is -infinity to infinity. Your range is -infinity to -2 with a bracket. Your x-intercepts are none. And then your y-intercept is 0, -2. So see if you can get those answers. If you cannot, and you are very curious and want to know, because hey, it's going to be on your test and you've got to know either way, come and let me know, okay? And I'll help you guys individually on this one if you don't know how I got one of those answers. So this is a long video. Let me know if you have any questions, not just over this one, but any questions in general. Pause this video, rewind it as you need to, and I'll see you next time.